Hi everyone. This is a video on what is a probability distribution, and um, we're going to start by defining what a probability distribution is. And if I open the screen right here, the definition of a probability distribution, all it is a table, just like we had frequency distributions, frequency tables. We're now going to have a probability distribution. It's a table of probabilities rather than a table of frequencies for the outcomes of a random variable x. Now that's a very fancy way of explaining giving this variable is just whatever it is that we're doing or whatever our experiment is. For our purposes today, we are only going to be looking at what we call discrete random variables. Later, we'll get into continuous random variables, but discrete random variables just mean that our variables are countable. Okay, so for example, how many yellow M&Ms did we get? You could have picked 1, or you could have picked 2, but you couldn't have picked 2.5 M&Ms. Yellow M&M. So it's just whatever your experiment is, it is going to involve whole numbers that are countable. Okay, so let's take a look at an example of a probability distribution. Let's say my experiment is tossing a coin, just a quarter, something like that, a coin, 3 times. Okay, now we've done this a lot in class. So my question is, first of all, how many possible outcomes are there? How many outcomes? Okay, outcomes. Now, we could do this through our counting techniques. We know that we're going to toss 3 coins, or we're going to toss 1 coin 3 times, however you want to look at it. So we have 3 events, and we know that there's 2 outcomes, a head or a tail for the first one, 2 outcomes, a head or a tail for the second one, 2 outcomes for the third, a head or a tail. So it equals 8. So we know that for whatever the probability is, our probability of any event, as we know, is always the number of successes out of the total possible outcomes. Okay? You should be sick of this definition by now. All right, so what we've just found here is the denominator. There are 8 possible outcomes. Okay, so let's think about the numerator. What are the number of successes? Well, a success for this problem we have defined. It is the number of heads. It's the number of heads. So that becomes that is what we have decided is a success. All right, for this experiment, tossing a head is a success. Well, one possibility is that we could toss the coin 3 times and we could get 0 heads. One of the outcomes, and I'm going to do this over here in a table, x is number of heads in 3 tosses of a coin, in 3 tosses. Okay, so one possibility is that we toss that coin 3 times and 0 of our outcomes are successes, meaning we get 0 heads. Or, in other words, we must get a tail, followed by a tail, followed by another tail. Well, what is the probability of that happening? Well, we know that. The probability of getting 1, 2, 3 tails is going to be, well, the probability the first one is a tail is 1/2, 1/2, times the probability that the second one is a tail is also 1/2, times the probability that the third one, and so on. We're going to get 1/8, which is just what we expected because we knew there were 8 possible outcomes, one of which is these 3 tails. One of which is the 3 tails. So I'm going to write that up here. The probability of 0 heads is 1/8. Okay, and with probability distribution, we quite often will do this in fractions. So if you use your calculator and you 1 divided by 8, you will get 0.125. Okay, that is so that's all it is a probability. Well, what's another possible outcome? Well, we could get 1 head or 1 success and 0. And that would mean the other 2 are tails. one of the three that we roll, that we toss, ends up being a head. So if you think about that, we know that that's the probability of a head, a tail, and another tail. One head. Plus, we could have to arrange all these different outcomes, which of course is 3 factorial. We end up with, or 3 factorial divided by 2 factorial because we have the repeats. So just quickly listing them. Head, I'm sorry, undo that. Sorry. One other possibility would be plus the probability of a tail and then a head and then another tail. And the third thing that could happen is one tail, the head could come last. Whew. Can't seem to read. The last one is the head. This middle one is the tail. So those are the only 3 outcomes for getting 2 tails and 1 head, or in other words, 1 success. And then each of these is going to equal that 1/8. We go through them individually. And you should be fairly comfortable with this by now. So this is just multiple events, and then it's kind of like the or. That's what we could get the head first, or we could get the head second, or we could get the head third. You add up those 3 different probabilities, and you're going to get 3 out of the 8. So, and then 3 divided by 8 is going to equal 0.375. Okay. So that's all this means, is that the probability of getting 1 head is 0.375. That's all a probability distribution is. It's just a table of the probabilities where you're listing everything that can possibly happen. So another thing that could happen is that we have what's called 2 successes. We're going to call this, again, remember that tossing a head for this experiment is the success. So understand the concept of successes and failures is really important now moving forward. All right. Okay, so a success in this case would be 2 heads. So just quickly thinking about that, what's the probability of 2 heads happening? Well, it's just going to be that 1/8 again, but then how many different ways can we get 2 heads? Well, you could get the head first and the head second and then a tail. You could get a head first and then a tail and then the head third, or you could get the tail first and then the 2 heads. I think you get the idea. So again, there's 3 ways. 3 out of the 8, do it on your calculator, is also 3.375. Okay. And then what's the last thing that could happen? We could toss that coin 3 times, and all 3 times we are going to get a head. What is the probability of that happening? Well, that's just like this one over here. The probability of a head, then a head, then a head is going to be the 0.125. And that is what we call a probability distribution. Okay, what does this tell us? Okay, one thing we can do is we can find the mean of a probability distribution. Okay, and that the formula is right down here. And this is a new symbol you're seeing. It is the Greek letter mu. In the past, we've identified the mean with a symbol of x with a line over it. Okay, that meant the mean of a sample. Okay. We also have another symbol for mean, which means the mean of the population, and I'll get more into this about in class, but these 2 symbols both are symbols for finding the mean. Okay, so the formula for finding the mean of a probability distribution is the sum, remember that sigma sign meant sum, of x times each x times its probability. All right, so let's take a minute and do that. So what I'm going to do with this probability distribution is I'm going to add a 3rd column right here where I multiply each x times its probability. All right, and don't forget that x again was the number of heads in 3 tosses of a coin. That's what x means in this probability distribution. All right, so the first one is the probability of getting 0 heads, or in other words, all 3 tails. And 0 times 0.125 is 0. The next one, 1 times 0.375 is 0.375. And remember, that means the probability of one head, which would mean you have one head and two tails. Because every time, each one of these means the coin is being tossed 3 times. All of these are just outcomes of the number of heads given that you toss the coin 3 times. Okay? All right. So now if you do this on your calculator 2 times, and so we're multiplying these, 2 times 0.375 is equal to 0.75. And the last one, 0.125 times 3 is equal to 0.375. And then what we want to do is we want to sum up this column right here. Okay, so just do that on your calculator. That's all this fancy formula over here means, that you multiply this column times this column and get this column over here and then sum up this column. That's it. That's how you find the mean. So we're going to add up the 0.375 plus the 0.75 plus the 0.375, and we will end up with the mean is equal to 0.375, which should make sense, equals 1.5. And what does that mean? This is the mean, or the average number of heads. We go back to our success. This is heads. So that means mean is also the expected value. The expected value. If we were to toss 3 coins, the expected number of heads would be 1.5. Okay. Now, of course, we can't get 1.5 heads, but it just means, if you did it over and over and over and over again and averaged out the number of times you got heads, this is what it would average out to, 1.5 out of 3 tosses, half of them. And that's what a probability distribution is. We are also going to find what we call the standard deviation. Now, we've talked about that before. The standard deviation also has 2 symbols. We've been using the letter S for the sample, the standard deviation of a sample. Now we're going to add to that another symbol, which is the Greek letter sigma, which means the standard deviation for a population. All right, and I am not going to go through that here. We are going to calculate the standard deviation on our calculators. We will do that in class. Okay, so now you know what a probability distribution is. In the next video, we'll talk about a very specific type of probability distribution called a binomial probability distribution. Okay, good luck.